one of the most abundant substances on Earth, constantly changing its form, and in most of its forms, constantly moving in an endless cycle. In part of the cycle, water leaves the surface of the Earth, evaporating to become part of the atmosphere. Clouds form from invisible water vapor in the air. We're using a time-lapse camera to speed up the cloud movements. You can see the front edge of this cloud bank changing back to invisible water vapor. To see how the water cycle operates, we can do some experiments. A plastic box of air to represent the atmosphere, and inside the box, a small dish, which we can fill with water to represent the ocean. We want to see how evaporation is affected by temperature, so we'll also use a Celsius thermometer and a fan to circulate the air in the box to maintain the temperature. One side of the box is movable. We can use it to draw air in or force air out. To start the evaporation experiment, we're forcing the air out of the box through this small opening. To measure the amount of evaporation, we want the air to be as dry as possible, so we'll draw in fresh air through a chemical that will dry it out. Now the air in the box is as dry as we can make it. To make the box airtight, we'll close off the tube. Into the small dish goes a measured amount of water. Inside the box, the air temperature is 25 degrees Celsius, about room temperature. As the water evaporates, a time-lapse camera compresses 48 hours into a few seconds. At a certain point, the air can hold no more moisture, and evaporation stops. If we use a sun lamp to increase the temperature, will more water evaporate? To maintain an even temperature, we'll circulate the air in the box. 35 degrees Celsius. That's 95 Fahrenheit. At the warmer temperature, more water evaporates in a shorter time. But after 35 hours, the evaporation stops again. Why is that? What will happen if we lower the temperature back to normal room temperature? At the lower temperature, some of the water vapor in the air is changed back to liquid water. This change is called condensation. Here's another example of condensation. Coming directly from the tea kettle is invisible water vapor. As this hot vapor mixes with the cooler air of the room, it condenses and forms a cloud. The same thing happens high in the atmosphere. The higher you go, the colder the air becomes. Moist air may be carried by the wind up a mountainside. As the air is cooled, it gives up its water vapor to form clouds. So clouds can form whenever moist air is cooled. But there's more to it than that. In our experiment, we saw water vapor condense on a cold surface. But clouds form in mid-air. There's no surface on which the water vapor can condense. Or is there? The air over the ocean contains many tiny crystals of salt thrown out by the churning waves of the sea. We can see some of these salt crystals under a microscope. These are surfaces on which water vapor can condense. Elsewhere, particles of dust or soot may serve the same purpose. Another experiment can demonstrate something else about the formation of clouds. Smoke from the candle leaves tiny particles of soot inside the test tube. We'll add some moisture as well. By moving the plunger, we can raise or lower the air pressure in the test tube. A cloud forms when the air pressure is lowered and disappears when the air pressure is raised again. So, lower air pressure is also a factor in the formation of clouds. There's another way in which air pressure and temperature are important to the water cycle. They govern the movement of air and of the water vapor in the air. Warm air tends to rise because it's not as dense as cooler air. As it rises, it becomes cooler and begins to fall again. An air current like this may move in a small local area, or it may circulate on a much larger scale, carrying water vapor for long distances around the Earth. The energy for this movement comes from the sun. We'll show what happens by using a spotlight to represent the sun and a screen to break the light into a pattern. Each circle of light represents the same amount of heat energy. As we move away from the equator, the circles of light are more spread out. The heat energy is not as concentrated, so the air is cooler. Because the equator receives more heat energy, the tropical air can hold a great deal of water vapor. So most of the water vapor in the atmosphere comes from tropical regions. This moist tropical air is circulated from the equator to other parts of the Earth, both north and south. Other cycles or wind patterns carry moist air to more remote parts of the Earth. The turning of the Earth and other forces change the shape of these wind patterns. To complete the water cycle, one more step is needed. What causes water to leave the atmosphere and return to Earth once more? An experiment will show one of the ways scientists believe it may happen. Inside the clear plastic box, the air contains water vapor and particles of soot. Dry ice will cool the box very quickly to a very low temperature. The water vapor has frozen into tiny crystals of ice that float in the air. We can watch the crystals growing by looking at them under a microscope. As the ice crystals grow, they become too heavy to remain floating in the air, and they'll soon begin to fall. If they fall through warmer air, the ice crystals will melt and reach the ground as rain. So the water which left the surface of the Earth to become part of the atmosphere has returned to Earth once more. Rivers, formed by rain and melting snow, soon rejoin the sea, and the water cycle is complete. But the cycle never really stops. Water continues to change its form by evaporation and condensation. And in the air, water continues to move. Movement and change of form, both important parts of the water cycle.